Okay, so now we're going to look at the test bench. Before we are looking at the waveforms, I'm going to look at the test bench itself. So I'm using the standard libraries, initializing the entity Pong test bench, the architecture behavioral of Pong, with a constant wait time. This is the bit width of our baud rate. Its use will be clear later. It is slightly higher than the actual bit rate because some bugs can occur when our signal is a bit too slow or a bit too fast. So that's why I put it on this. Then we have our clock signal, the RX pin from the UART TX pin. The controls are the buttons. And then score P1, score P2, so player 1, player 2, which is the data we receive from the application. Then we have our DUT. This is the instantiation of Pong, where of course everything is passed through. So that's this part. Then we scroll a bit down. Here we have a few processes. One process is responsible for the clock. This has a total period of 5 nanoseconds. And then, of course, it has to flip again. The actual clock has a period of 10 nanoseconds. Then our stimuli, this is for the TX pin. Because the TX pin is automated to be sent every 100 milliseconds, we only need to control the buttons. So this is being simulated, no buttons pressed, button 1, button 2, button 3, button 4, all together. And this is looping at 10 milliseconds intervals 100 times. And when that's done, our simulation will end. This takes in total 6 seconds, so it's reasonable and it's nice for debugging. Then we're going to look at the Stimuli RX. Stimuli RX is, it has a data variable. This contains what we should get in. It is, for example, in this case, 101.1.1.1.0, and we can then dynamically change it throughout the process to simulate any signal that we want for the UART. So we start idle, start bit, and then here we have the wait time. A wait time is just, as I said before, the time for one bit. And when done, it stops, idle, and starts over. I also simulate a bit further down how it is when there is no idle time, which we will see in a minute. So let's start off by looking at whether the transmitting pin works. So here we can see every 100 milliseconds it is sending our signal. If we are zooming in on this part, we can see here we have our controls. This is 1000. Now the way the app works, in its processing of the bits, it will use the first bit as an offset bit. So then 001, that's this one, and then the 3 leftover bits are 0. Then we will look at the second one at 200 milliseconds. So at this point, the second button is being pressed, so 0010, which we can also see here that it is right. So the TX pin works, as we can see here. So let's get a look at the RX pin. So here is the data we are getting in. It's low for one period. This is the start bit. That's a 0, a 1, a 0, 1, 0, 1, 0, 1. And indeed, that's the same. Also here we see as soon as the start bit comes, Rx done is false. It's testing. What the input is, it becomes high when it's sure it's this number, so we can read it out. This one is exactly the same data, so I'm not going to go over that one again. And here we have 1, 3 zeros, 1, 2 zeros, 1. Let's see if it's the same. It is indeed a 1, 3 zeros, a 1, 2 zeros, a 1. And here we see this 1, then I stop it, and pretty much immediately afterwards there is the start of the next byte. So let's see if this one works as well. So we have 0, 2 ones, a 0, 3 ones, and a 0, and then I stop it, and indeed it is right. So it always goes high because we need to be at least 1 pulse in idle before we can go to hold, and that's how we are also sure that the input will be set to here our score. So as soon as it's done, we have this value which is equal in hexadecimal to AA, and indeed it immediately changes. And here the same happens. This is 8, that's 9, so let's look. Indeed it works. Here this is 7, 6, and also this one does what it should. So the RX pin is also working. Now there are a million signals in here, like for sampling and things like that, so I'm not going to go over all of them because this is already 7 minutes, and I think we would be here half an hour then.